Hi everyone. In this video, we are going to show how to use solid phase extraction or SPE as a sample preparation step for high performance liquid chromatography or HPLC. SPE is an extractive technique which aims to separate a target analyte or a group of compounds from a sample matrix. The three main goals of SPE are to eliminate the interference caused by other compounds in the matrix, to concentrate the sample, and to transfer the analyte of interest from one solvent to another. There are many types of SPE formats available. Sizes vary from 1 ml to 6 ml syringe cartridges, as well as 96 well microtiter SPE plates. Some other formats include cartridges as long as 25 cm, which can be attached to a liquid chromatography or LC system. In the Natural Products and Peptidomics Laboratory, College of Arts and Sciences, UP Manila, the solid phase extraction setup uses 4 components: a solid phase extraction cartridge, a SPE manifold, a fraction collector, which in this case is a 10 ml beaker, and a mechanical pump which draws pressure from the manifold and in turns draw the liquid through the SPE cartridge. The pump is connected to a manifold with a rubber tubing, and the pressure is controlled through a pressure gauge. For this video, we are using the HLB Oasis Prime 6 ml cartridge from Waters. This SPE cartridge is packed with 500 mg hydrophilic lipophilic copolymer of N-vinyl pyrrolidone and divinylbenzene, which is reported with good retention for both polar and non-polar compounds. Generally, SPE consists of 4 steps: column preparation, sample loading, column post-wash, and sample desorption. Column conditioning includes 2 steps: column priming with an organic solvent, and pre-column wash with a more polar solvent such as water. The column priming prepares the sorbent to accept or retain the analyte of interest. We are using 5 ml of methanol for the column priming step. Some parts of this video are time-lapsed because it takes time for the solvent to pass through the cartridge depending on the interaction between the liquid mobile phase and the solid adsorbent. For the pre-column wash, we are using 6 ml of HPLC grade or ultra pure water. In this step, the water flushes out the excess methanol from the cartridge and prepares it for the sample loading step. For the sample loading step, we are using 5 ml of plant extract dissolved in 60% dimethyl sulfoxide in water. Notice that I slightly changed the pressure of the pump as different solvents pass through the adsorbent at a different rate. Adjusting the pressure of the pump makes the flow rate a little more constant when switching between solvents. For SPE and other chromatography techniques, flow rate is monitored and kept at constant rate for method replicability. The post-column wash uses 6 milliliters of HPLC grade or ultra-pure water. This step elutes the other compounds which were not retained by the sorbent as well as the excess loading solvent. Other methods may also use a solvent system of miscible organic solvents such as 5% methanol in water or 50% acetonitrile in water. The final step for SPE is the sample desorption or elution step. In this step, the analytes or compounds retained in the sorbent were eluted with an organic solvent such as methanol. 10 milliliters of methanol were used as the sample desorption solvent in this video. Notice that the green band retained in the sorbent now moves toward to the tip of the cartridge but is not fully eluted. However, the fraction collected can be observed to have a lime color, which means some of the compounds from the extract is eluted using methanol as a solvent. The remaining green visible band is more nonpolar in nature as it was retained in the sorbent after the first desorption using methanol. Solid phase extraction may have more than one elution step. To elute the remaining green band from the sorbent, 6 milliliters of ethyl acetate was used, a less polar solvent than methanol. After the SPE procedure, the fractions collected were labeled load, wash, elution 1, which used methanol as the eluting solvent, and elution 2, which used ethyl acetate. 500 milliliters alico from each sample were transferred into polypropylene HPLC vial kits with 2 micrometers filter labeled accordingly. These vials were loaded into the HPLC equipment for analysis.